Alright, so today we are having a look at... Whoa, what is this? Hello! This should be, I think, part 4 of the Sega TeraDrive power supply repair series, I suppose. So we're blindly replacing capacitors and IC chips. We're going to see where that takes us. Hopefully it repairs the power supply. That would be really, really nice. But I guess we'll find out as we go. So this will be quite a long video. We're going to be desoldering. Here are all the capacitors. So these are all the different ones that we've got. Look at that. That one, you couldn't get any less than 5. I need one of them. The rest I think I'll just eat. 6800 microfarad, 10 volt. Look at the size of them. Huge. Imagine if that was 400 volt, they'd be like this big. Anyway, enough of that. So bad voltages from Model 3s. This is from the one that actually has the hard drive. I have to remind myself every time I do this, because otherwise I forget. So the TeraDrive power supply, we've got 7 screws around the outside. Just to get the top casing off, and a little bit of screwdriver. Right off the bat. Oh, that's the other thing I don't like. I always end up doing these videos late at night, so there's never sufficient lighting for the YouTube video. That's fine. Okay, so very small screws. It's fine because, let's be honest, I'm not the one watching the video. You are. I do apologise. So let's see how long this video ends up being. So we've got the Hakko 808 desolder gun, which is superb for desoldering. And we're also going to be messing around with the, well, some of these capacitors are in the hundreds of volts range. So I'm going to want to be pretty careful when it comes to that. It just separates like magic. There we go. Look at that. Nice sharp edges. Oh yeah, I love sharp edges. Okay, so now I've got to remember how to get the thing out. How does this all come apart? So there's the internals, just in case you've forgotten. Actually zoom in, I've got the nice big zoomy lens on today. You can zoom in something fierce. Focusing, that's a different thing. There we go. So we're pretty much replacing every electrolytic cap you can see. So there's 3 there, there's another one. There's a couple hiding in the middle. There's a whole bunch over here in this corner. There's that tall one. There he is. And we've also got one single, I think it's a B12 something, B1274, which is either this one here, I suspect it's this one here, on this side. I wanted this one to turn up. That's the one of the guys on the assembler thread said to replace, but it hasn't turned up yet. So I figure, you know what, I'll start. I'm going to start on this, get the capacitors done. Everything will turn up Monday. I'll just slap in the last few things. It'll all be perfect. Knowing my luck though, everything's probably lost in the mail. So, I want to get that fan disconnected, because it is just going to be in the way. Now it's very dangerous working on power supplies because they have a primary and a secondary circuit. The primary circuit, from what I understand, is the really zappy, dangerous bit with things like this capacitor. You're a big un. It's only big because it's got a lot of volts. It's only 330 microfarad, but I'm sure that will deliver a nice zap if I mean, really, I should discharge this, which we'll have a look at. I'll see if I can just short it with the screwdriver. That's one way to do it, not a very safe way, but I don't see what option I have. I mean, I can try and desolder it without touching it, but we'll see how we go. Now let's have a look, just see if I've got that replacement capacitor. That's a big one. 200 volt 330, you say. What's in here? What is in here? Well, I'll be damned. Rubicon has improved the technology of Rubicon in the past. Look at that, it's like its diameter's shrunk quite a bit. So that's good. Gosh, this is heavy. It's got some weight. I like it, it's got a bit of weight. Unlike me, losing weight. Okay, so the next thing we need to do is get the power switch out and the power switch is all tied into the, well, where the power plug's in. So, little flat screw and a second screw there. It was funny, I was reading the comments on the... Ooh, my things are selling on eBay. Kingston RAM, how exciting. A gentleman, or gentle lady, or whatever they were, decided to just chime in and say that I should edit my videos properly. Now, I don't know if any of you who have been watching this channel long enough know that I generally am pretty lazy when it comes to doing things like that. The most editing I've ever really done is probably the subscription video, and even that was just, I literally copied that from the previous 2 times, and I just changed some things, like adding a cool background. Yeah, I'm pretty bad at that. But no one noticed, so it's all good. Just gotta be very careful not to drop this nut into the depths below. And what else have we got here? Come on, get off the damn thing. There we go, we've got a washery thing. So that's the ground. So I mustn't forget that that is the ground. Now this bit is just flopping around, that's good. Next part is probably the, I guess the power supply itself. Oh no, hang on, does this come out? No, but it does go longer. Okay, that'll do, that'll do. So then we've got 2 screws on the power supply main board. Are they the same? Will you make my life easy? Yes, good on you, IBM. Just pull this out, and now we are free to work on it. So, first up, let's go ahead and try shorting that massive capacitor, see what happens. I might just get a longer screwdriver and maybe put on some protective goggles. But in theory, nothing. That's good. That's good. Woo! Gosh, that's a lot of solder on those points. Should be interesting. Should be very interesting. Okay, so where should we start? Well, let's start with the big one, because that's the one I've got out. I need my desolder gun heated up, which in hindsight I probably should have done before I started taking the screws out. We've got that little guy. I've got a whole bunch of these. Pretty sure I only need the one, given there's only one in there. There we go, that's a nice one. 10 volt 6800. 10 volt 6800. I have tried to stick with the original voltages as much as I could in case anyone repairs this. Oh, in case 1, I repair this, and 2, if in the future someone else repairs it, or needs to repair it, because I didn't repair it properly, or it's been 20 years, and they want the values, and the values are all mixed up. Because for example, I could put a, say, a 16 volt 6800 instead of a 10, and the next person along puts in a 25 instead of a 16, which was instead of a 10, and eventually things start to get a bit odd. I'm not quite sure what effect that has, but I'm sure it's not good. So we've got a 16 volt 1000 microfarad. There's a 35. Where does this one live? I bet it's one of these two here. Well, it's a bit out of frame, isn't it? Let's see if we can fix that up. So you can get in on the action. It's the Hacko 808 in the background. You'll be delighted to know. Okay, just pop all that rubbish over there. How you going, Hacko? You getting nice and toasty? It's going to need to be toasty. What's this? I've got 3 of these. I've got 3 1000 microfarad 35 volt. 1. 1. And I've gone for mostly Rubicon, as always. I think they're all Rubicon actually. Rubicon. What's this one? Why doesn't this one have a brand? That's interesting. It looks like Rubicon though. Wait. Oh yeah, 35 volt, that's right. I've always loved my Rubicons. Rubicons. 3300 UF, 10 volt, that's on the other side over here. Starting to get to know where the capacitors go. That's a bit concerning. We've got some little ones which are 10 UF, 50 volt, 47 UF, 50 volt. We've got a stack of those. Need 1, 4 spare. Yeah, that'll be right. And a 400 volt, 4.7 UF. That must be this one in here. Oh, there's the 16. That's the 16 volt 1000. There are the smaller ones. 3 smaller ones. I think I should have 2, and I do. Wow, I love it when things work out. Okay, well let's start with Le Massive Cap, as they say in Japan, since this is a Japanese unit. That makes perfect sense. Alright. Man, this is going to suck up a lot of heat. Whoa! I wonder if I need to put the bigger tip on. How thick are these wires? Why don't they fit? There we go, it's starting to melt away at the solder. Ever so slowly. Actually, it does look like these might be a bit thicker because it is a larger capacitor, you mustn't forget. Okay, we'll do that one last. Off to a great start. So that one's last. Stupid big ass capacitor. Where's the next one? This one over here. This one's small. It looks like it's on the secondary side. Oh wow, look at that. Off it comes. Come on, out you come. It's loose as a goose. So that is 16 volt 1000 UF. 16 volt 1000 UF. Now it's very important to check the polarity. Oh, look at that. This board has nice markings on it. Sanyo did do something right. I mean, I guess the power supply lasted a while. So negative is on that side, positive is on that side. So for the moment, I'm just going to pop these through and just bend the legs. And then I'll come back to it and solder it, probably. Haha, thanks Desolder gun. You're hilarious. Next we'll do the 35 volt 1000 UF. Nice tiny legs on this. Look at that. Wobble, wobble, wobble. Off the board it comes. Just checking these as I go to make sure they're... or if they are leaking. It'd be nice to see some really good leakage on one of them. So far these two have been clean. But now they've been replaced, they'll be good for a while. And even if they're not, it's fine. I put that in the right way, didn't I? Yes. Good. Yep. What's this one? 3300 UF 10 volt. That's the one right over in... That's an actual Sanyo branded capacitor. Oh, that stinks. Oh. Well, we found a leaker. Oh, man. Whoa! If you could smell that. You probably wouldn't. Oh no, you would notice. That's terrible. Okay, let's see if we can get a close-up of this little guy. So I've got the completely wrong lens on for this sort of thing, or do I? I can see it tracking it. Can't get a lock. There we go. So zoom into 1080p if you haven't already, and just have a look at that leg there. It's the stuff dreams are made of. Nasty. So that's one of the Sanyo branded ones. Now I don't know if Sanyo is a bit like Nichicon. I noticed that the PlayStation 1s, the later models, all had Nichicon power supplies. I don't know if that's a good thing or a bad thing. Especially when they were cutting down on cost in the later years. Yeah, alright. Nichicon aside, let's have it. Wow, that pad is... The good news is that the leakage has sort of... Oh wow, okay, that's cool. Let's get a look at this without melting anything. Oh, there's the big if. If not melt anything is good. So if we have a look on this side, nice and close. So in that, on the left-hand side there, you can actually see that the capacitor has sort of limited the amount of the way, well, you can't really see it, but it's limited the movement of the liquid from the capacitor. So I need to clean it up. So I'm going to get myself, well, you know what I'm going to get? Q-tips. A whole heap of them. Oh yeah, oh yeah, and a rubbish bin. Oh, it's all happening today. It's all happening today. This is very good news. Okay, so a bit of metho, as we use over here, because it isn't bad like the US stuff. 96% ethanol. So, the reason I was quite excited about that is because this is right next to, that's right, the 5-volt rail. It's nowhere near the 11-volt rail, but it's also near the grounds. So who knows, it could have just been this one capacitor. Instead I've got a whole army of capacitors at the ready, prepared to fight. For me! Good on them. Bless their souls. That are variable resistors, okay. It's pretty close to the, oh no, it's up on legs, that's good. Up on the stilts. Okay, this side's looking pretty good now. Let's flip it over. Clean up this other side. How much is actually... Wow. This isn't flux on the underside, it's leaked capacitor. Although the mylar on the other side looks okay. So that's probably just flux. Probably. How would I know? I can't tell. What's the difference? I don't even know. That is very good news. Gosh, I'm getting Q-tip over everything. All right. It's better than it was. Ish. Better-ish than it was. Ooh. Capacitors. Is that a capacitor? It is. It's the big capacitor, the tall one. It's not actually connected to the board. It's interesting. The solder has just, it's a dry joint. Well, that's going to be easy to desolder. Yep, the solder has actually just disappeared. So there's obviously something gone bad under here. Let's see if I can get some more light on this side. So around here, so if this leaked, yeah, it looks like it has leaked. Something has leaked all the way. It's not flux, it's actually, because this is clean board, and around there upward it's clean board, which means it's just the low voltage side that seems to be affected. Now, of course, that leakage could have come from this capacitor and gone all the way over here, because it would use, I guess, surface tension to stick to the back of the board and move along slowly. Oh well, let's, oh, we've really got our work cut out for us now. Blimey! Here I was thinking it would be that easy. Just gotta make sure I get all the little metal shards out of here. So that means I need to sort of clean everything in this area. It's a lot of cleaning. It's a lot of cleaning. It sort of does look like a bit of the PCB's been eaten away at too. But this is good, I think, because it shows that there actually is a fault, which means we're not so much blindly stabbing in the dark anymore. I mean, really, I guess I should have picked that up earlier, but I didn't. Cleaning my board, cleaning my board. Looks like this might have been repaired previously. In particular the ground cables and whatever's around here. Interesting. Alright, so what were we doing? We just popped... No, we haven't put it in. We were going to put it in. Where is it? I don't even know what it was. What did I take out? Was it... Yes, it was that. Without a doubt. So positives on that side. Negative is on this side. Alright, you know what we're going to do? I'm going to cut, do some more cleaning, and we'll come back, because really I can do this without you. I promise. Alright, so when the lines start to blur of what is flux and what is leaked capacitor, it's probably time to stop cleaning. So now we just got to keep doing capacitors. So what are we up to? We've got 50 volt, we've got 47 UFs and 10 UFs. So let's see if we can locate them on the board. Oh, there's one down there. So that looks like it's below a bunch of things. Don't you hate it when you don't know which pins it is? It's the very first one, or if in line with that. So I'm going to say it's those two. If I'm wrong, we'll know. Yep, that looks like a capacitor, the way it moved. Negative is toward me. Extracting, looking for any leakage. Looks clean. Give the board a bit of a wipe. This side. Yep, all's well. Negative is toward me, and it was a 10 UF. Come on, 50 volt. 10 UF 50 volt. All of these are rated at 105 degrees. So that means if they were running at 105 degrees, they would last, well, whatever their rated time is. Which in most cases is somewhere between 1,000 hours and 5,000 hours. In most cases. I tend to get the ones closer to 5,000. In fact, I'm waiting on some from element 14. They're really being a bit slack. Bring those two that way. What else we got? We've got another one down there. It's sort of near the blue thing. So we reckon it's those two or those two. What else is below the blue thing? Nothing. So it's definitely those two. Somewhere. Solder gun will show us how. Just let it heat all the solder for a second, right the way through. That was the worst example ever. Ah, looks a bit better. I have desoldered the right thing. Yes, I have. Good. So negative is that way. Good, and it's marked on the thing, and there's no leakage from that one. The littler capacitors are generally pretty safe. What was that? These should be both 10 UF. Both 10 UF. Sanyo branded as well. I guess if I was making a power supply, I'd use my own capacitors. Unless I didn't trust them, which is why it's interesting. The big 400 one is a Rubicon. It's like Sanyo thought, no, I don't quite trust myself. I'm still new at capacitors. Or I'm so old at capacitors, my memory is failing and I've forgotten the recipe. Be careful when reaching around this board. I don't want to get zapped. Really don't want to get zapped. And a lucky last is just above those ones, okay. Well, not lucky last, it's still two big ones. Well, there's a bit of gunk on top of the board, which sort of makes me think that that big cap might have also leaked. So where are we looking, where are we looking? Somewhere around there-ish. And it looks like it's going acrossways, so it's probably these 2 points here. Oh, I can never go back to desolder braid, it's just not the same. Let's have a look, see if I've got the right one. Negative is going toward the side, and that's loose, which means it should just fall off. And there it is. Fallen off. Looking good. Negative goes toward that way. Now, when buying capacitors for power supplies and other things, you also need to consider your ripple, your ESR, and all those other things that I never consider. Yes, well, I should if I had any electrical engineering training, which I do not. Anyway, next capacitor is this one, which already has one of the legs conveniently desoldered. Thanks, corrosion. It's also got some hot glue on the other side to hold it in place, I noticed. Oh. Oh, that one's given off a bit of a smell. It's loose, so let's see if it just lifts out without ripping all the traces off. So positive is toward my left. Wait, is that glue? I hope that's glue. If that's not glue, that's no, that has to be. Is it electrolytic? It has leaked. Let's get a close-up of that one. I mean, a distant shot of it. So that's definitely leaked. Looking at those two pins there. So that was one that Ronnie was concerned about, and he is damn right. Sure enough, it has leaked to bilio. So that's good. At least 2 leaky capacitors so far. It's not terribly good. It's probably actually quite bad. That should be a pretty quick pad to clean on the top. So let's do that with the camera rolling. Okay, and the replacement is here. Negative away from me. Just see if I can get the gunk off. There's a bit of gunk in the hole. Oh, that's heavy. Yep, that would be putting it in backwards. That is putting it in the right way. Gosh, thick legs on that one. Not as thick as the biggie though, which is my second final target. Got one more, sort of in the middle here, in the high voltage area. I think it's going to be, that's that thing. There's a resistor next to it. It's going to be those two, I reckon. These two here. If I'm wrong, so be it. I will resolder whatever I've just desoldered. Gosh, I'm good. Alright. That's an Elna. Now, Elna I wasn't too familiar with. But they are actually present in some of the Mega Drives and possibly Elnas, Mega Drives. I do remember seeing them in Mega Drives. Rubicons are also in Mega Drives, which is how I became so in love with them. So here we've got Elna. I've got a 4.7 UF. The original is 350 volt. The replacement is 400. I couldn't find an equivalent. It's a lot, well, it's quite a bit shorter. It's about 25% shorter, I'd say, or well, you know, at least a fifth shorter. It's about the same width by the looks. Yep. So hopefully that won't be too detrimental to the circuit. 400 volt section. Just check that the pad's nice and clean, and it is. No, that must be glue. Yeah, that's glue on that capacitor. I can see it on some of the other ones. Unless, of course, that's leakage as well, which would be very bad. Positive and negative. Oh, just positive, that's fine. I guess there's no need to be negative. Who would have thought when I started this project that I'd just end up replacing the bloody capacitors? Honestly, I should have listened to my other video where I said caps fix everything. One of those SNES ones. Okay, so now I've only got one more capacitor to fit, and I can't get my desolder thing around the legs because they're too thick. Give it one more try. See if I can cheat, see if I can just suck the solder off the side. Ah, I'm such a cheat. Ha! Yeah, I need a bigger bit. Easy does it. So I'll probably want to use desolder braid for that. Last little bit. So desolder gun off. I need to go wet my sponge for my soldering iron, which will help me remove this. So if I wiggle that, it'll just crack the solder pads, which would be very bad. So I'll be right back. Okie dokie. So my soldering iron is hopefully ready. 350 degrees of pure Celsius. Okay, I'm using the desolder braid, which is always a pleasure. I could probably just heat the pad things around it and see what happens. Can't tell if I'm helping or not. It's a very thick leg. Ooh. See if I can get it to move at all. I heat it. Jeez Louise. Might actually be easiest for me to add a bit more solder. Chances are this cap is rock solid. It's a bloody Rubicon. You reflow it, you can often use the desolder braid to suck it all off again. It's a vicious cycle. I'm gonna want to air out my bedroom before I go to sleep tonight, I think. Ooh. Everything smells like blue, the color blue. hot from soldering. Forgot. My bad. There we go. That's maybe a bit better. Myself a nice stretched out piece of desolder braid. Plop it over the area I want to target. Ah, I forgot how hot desolder braid gets so quickly. I didn't even know I was touching it. Whew, that is giving up an interesting odour. I think that's doing pretty well. Here we go on this one as well, this other prong. Ooh, some more of that interesting odour. Wonder if this one has leaked. That would be interesting. And ruin all faith I had in Rubicon. Because of one giant capacitor they couldn't do right. Let's try this bit of glue. Aha! There we go. Negative toward me. Holy crud. 200 volt, 330 UF. Look at that, it's actually got different legs. And of course it hasn't leaked. Double checks for leaks. Because Rubicon know how to make a capacitor. Hopefully the legs being a bit thicker isn't going to be a problem. I guess we'll find out when we turned on for the first time and run away because the house is on fire. Good thing I don't hold the deed, although insurance would be pretty nice. Okay, so there's a bit of glue. Let's get the glue up using then again, let's leave the glue there. Oh, it's perfect. Ish. I'll just double check that one because it is a very big one. If it explodes, because I have it backwards, it's going to explode in a very big way. Negative is toward me, absolutely. No doubting that. Alright. Well, now we're ready to solder all the bits on. So let's power up the soldering iron again and wait for it.